Okay, guys, we're back for day 3 of lesson 8. I don't know why I wrote 7 on my paper, but I did. But what we're going to look at today is estimating with fractions. All right. So we're going to start with this problem where Jim stands on a dock that's 3 3/4 feet above the lake surface. He dives down 12.5 feet below the dock. What is Jim's vertical position to the lake surface? Show that your answer is reasonable. So we have a couple things to unpack here, and the way we're going to do, we're going to look at this number line, and I'm going to ask you, what do the numbers 3 3/4 and negative 12.5 represent on this number line? So first we have 3 3/4, which is right here, right? And notice that the 0 mark is right here, and then that negative 12.5 is up here on this line, on the arc going back. All right. So what that tells us is we need to look at what 3 3/4 represents. 3 3/4 is the height of the dock above the surface, right? And negative 12.5, that's the distance that the dive ended below the dock itself, right? So below the dock itself is negative 12.5 feet to the end of the dive. What we're trying to find out is how far this dive is relative to this 0 point right here. So what does 0 represent in this equation? 0 is actually the surface of the water, right? We covered the vocabulary word relative to a couple of chapters ago. Relative to resets your 0 line, all right? And so that's how this starts. We're 3 3/4 feet above the lake surface, and now we have to find out how far below we went. And if you follow this arrow, we end up down here at negative 8 3/4. That's how we model it on a number line. Now, we can also model it by rounding, right? And we're going to round to the nearest integer. The reason we round to the nearest integer is because rounding to the nearest integer gives you the most accurate estimate, because when we do that, there's a lower margin of error, right? So here we're going to round 3 3/4 up to 4, because that's more than 1/2, and we're going to round negative 12.5 to 13, because anything that's 0.5 or above goes to the next number, right? So we go to negative 13. All right. So now let's take a look and answer some questions about this. They want us to write and solve an equation which shows Jim's vertical location using values rounded to the nearest integer. All right, I'm going to show you where I've done that already. And for some reason, I misplaced a pen, but it's right here, right? So here's where I've done it already. It's number 9, is 4 plus a negative 13, that gives us a negative 9, right? So this is the equation you should be writing on number 9 in your notebook, right? In your instruction book. Now number 10 says, based on your estimate, is Jim's position relative to the surface of the lake? Is it definitely positive, definitely negative, or too close to 0 to tell, and you need to explain that? Well, let's take a look at that in context. So in the context of this problem, here's our estimate. We have 4 plus a negative 13, that's equal to negative 9. So based on that, I'm going to zoom out just a little bit so you can see the whole answer. Based on that estimate, right? So based on that estimate of negative 9 feet, Jim is definitely below the surface. So it's definitely negative, right? Negative number means below the surface. It would not be reasonable for him to be above the surface. So just based on our estimate of the integers, our actual value should show him definitely below the surface. And that's where number 11 comes in. Number 11, we're supposed to show this problem with the exact values. All right, so I've done that here. Exact values, I'm going to crank that up just a little bit so you can see a little better. We have 3 3/4 plus a negative 12 1/2. So the second step of that equation is to find the common denominator right there. And we find the common denominator to be 4. So we have 3 3/4 plus a negative 12 3/4. We're trying to find the difference, right? We're trying to find the distance from the surface of the water to the bottom of the dive. And we do that, we end up with negative 8 3/4 feet, right? Now here, the reason we've got that is 12 2/4 has a higher absolute value, so we automatically know the answer is going to be negative, right? So 12 3/4 has a higher absolute value than 3 3/4, so when we add them together, we know our answer is going to be negative, and then we just subtract the absolute values. All right, the next question says number 12 says, describe how solving the equation with integers help you solve the equation with exact values. Well, when we did it with integers, what happened is let me make it smaller once again. With integers, we knew that the answer would be negative based on the estimate, right? Using the actual numbers, I found a common denominator and subtracted the absolute values to get negative 8 3/4. Since my estimate was negative 9 feet, I knew that my answer of negative 8 3/4 was reasonable. All right, so that's how we use the estimate to find the answer. All right, so we're going to continue with the last part, which is the try it section. All right, so I want you to look at these two problems. Number 13 says a sugar water solution freezes at negative 1/8 degrees Celsius. A salt water solution freezes at negative 13.6 degrees Celsius. What's the difference between the freezing temperature in the sugar water solution and that of the salt water solution? Estimate to show that your answer is reasonable. Well, the key here is that we're not setting a new zero. So they want to know the difference. That's a subtraction problem. So we have negative 1/8, our estimate. We have negative 1/8, which we're going to, I need to hold this up now. We have a negative 1/8, which we're going to estimate to negative 2. And we have negative 13.6, which we're going to estimate to negative 14. So then we're going to keep change flip to get negative 2 plus 14, which gives us an answer of positive 12. Right? So now we can check our actual values, and we have negative 1.8 minus a negative 13.6. Right? So again, we check the absolute values. 13.6 is more positive. It has a higher absolute value. So we simply subtract the absolute values and we get 11.8. And since we estimated positive 12, positive 11.8 is clearly a reasonable answer. All right. And number 14, let's read the problem. Number 14, let me zoom that back in. Number 14, there's a cat. It says Cecilia's records the weight change in her cat over a 2-week period, right? What number does she record as a total weight change for her cat, right? Well, this doesn't tell us to estimate, but we can. If we look at these numbers, negative 5/16 is really close to 0, right? Because 8/16 is a half. So anything below that, we go down, so that's going to be 0. 3/8 is less than half, so that would go down to 0. So we would estimate 0 plus 0, and our total change estimate would be 0. So that tells us that when we do our actual numbers, our actual number should be close to 0. It doesn't really tell us if we're going to be above or below 0 until we get the common denominator. Our common denominator here is 16. So we have negative 5/16 plus 8/16, right? No, 6/16. I'm sorry, because 2 times 8 is 16, 2 times 3 is 6, right? So that will look, let me zoom this back in. That will look like this problem right here. Once you see that 6/16 has a higher absolute value than negative 5/16. So we know our answer is going to be positive, and we just want to subtract the absolute values. 6 minus 5 is 1, so we get 1/16 of a pound. Right, so here the total change is 1/16 of a pound. And to estimate that's a little tricky because both fractions are really close to 0, giving us 0 plus 0 equals 0. So it doesn't show us initially if we're going to have a positive or a negative, but it does show us that 1/16, which is very close to 0, is a reasonable answer. All right, so your homework that you're going to bring to school tomorrow and work on in class is page 73 and 74. You guys have a good night, and I will check in with you in the morning.